All right, pre-calc, we're going to go ahead and talk about our sum and difference formulas and identities. Here you can see we got a whole bunch of formulas for you. So we have our sum and difference of our sine function, and go ahead, take a pause, write it down if need be. We have sum and difference for our cosine functions. Again, go ahead, pause if need be. And then last down here, we have our sum and difference for our tangent functions. Go ahead, pause if need be. So we're going to be using all of these today, and just kind of showing how we can find some of these trig functions when they aren't necessarily on our unit circle. All right, so let's start here with example number 1. Not sure why that says those PPs right there, so let's kind of get rid of these. I think that was just a little bit of a typo. No problem, we'll get rid of them. All right, so we are talking about tangent of 75 degrees. Now, obviously, it's not one of the things that we talk about in terms of our unit circle and our special right triangles, so we're gonna have to break this up into something that can be on the unit circle that we can work with. So let's break this 75 up into tangent of 45 degrees plus 30 degrees. So we can both evaluate tangent of 45 degrees and 30 degrees. And what we're going to do is that we are going to be using this formula right here, right? So tangent of theta plus beta is equal to tangent of theta plus tangent of beta over 1 minus tangent theta times tangent beta. So we're going to go ahead and fill in what we need to here. So we have that this is equal to tangent of 45 degrees plus tangent of 30 degrees all over 1 minus tangent of 45 degrees times tangent of 30 degrees. Okay, and now let's go ahead and evaluate all of these and simplify. So when it gets to this part, it just is a little bit of some tricky kind of manipulation. So tangent 30 is root 3 over 3. Sorry, tangent 45 is 1. I started to fill in some things. Plus root 3 over 3 all over 1 minus 1 times root 3 over 3. So it can get a little bit tricky in terms of our order of operations, so just be patient with it. I'm going to change our 1 into 3 over 3, so we're going to have 3 plus square root 3 over 3 all over our 3 minus root 3 over 3. Okay, as we can see here is that we are going to have denominators, so these 3's are going to end up canceling. You can also think about it as multiplying by 3 over 3. Is equal to now 3 plus square root 3 over 3 minus root 3. Well, we know from algebra 2 that we can get rid of that denominator by multiplying by the conjugate, or we can get rid of the radical in the denominator by multiplying by the conjugate. So that's going to be 3 plus on that one. So a little bit of distribution. On the top, we have 9 plus 6 square root 3, let's make that 3 actually better, plus 3 is all over 9 minus 3, because it ends up being a difference of squares on the bottom. All right, so we now have 12 plus 6 square root 3 all over 6. And we can go ahead and we can reduce some things. So 6, 6, 12, this becomes 2. So final answer here is 2 plus root 3. And we did it. So you just evaluated sine of 75 degrees, and sine of 75 degrees is equal to 2 plus square root 3. Now a good check, of course, to take is, hey, is that in quadrant 1? What quadrant is? It's in quadrant 1, which means it should be positive. Yes, this is going to be a positive answer. So just kind of double checking positive and negatives, making sure you're on the right track with them. All right, so that was our tangent sum formula. Let's go ahead and let's look at sine of 156 degrees. So again, the whole goal of this is kind of just to go ahead and split up your degrees into degrees that you can evaluate using your unit circle. So we're going to actually, and this can be done several different ways, FYI. It doesn't have to be done the way that I'm showing you. So I'm actually going to go ahead and say sine of 225 degrees minus 60 degrees. And now this allows me to go ahead and use my difference formula here. So we're going to take sine of alpha cosine beta minus cosine alpha sine beta using 225 and 225 and 60 degrees. Okay, so we then have sine of 225 degrees times cosine of 60 degrees minus cosine of 225 degrees times sine of 60 degrees. All right, we're going to evaluate each one of these. So sine of 225 is negative root 2 over 2 times cosine of 60, 1/2 minus negative root 2 over 2 times root 3 over 2. So this ends up being negative root 2 over 4 plus, because the negatives there turn to positive, so plus square root 6 over 4. So our final answer here, I'm going to put some equal signs in here. Our final answer here is negative square root 2 plus square root 6 all over 4, right? Or if you kind of wanted to rearrange some things, I think it looks a little bit nicer if you put that square root of 6 out front. But either one of these are okay. And as a reminder there, we of course cannot combine those because you can't add different radicals. Sorry, this is the third time I'm doing it. Hopefully this box will pop up. No, it doesn't. So we just simply get our, I'll try the fourth one. There we go. There's our box for our answers there. All right, one more with cosine, because of course it works with radians as well, right? Cosine 11 pi over 12. So you figured out, which is like, hey, moral of the story is to split up your, your angle into two angles that you can evaluate. And this can be done so many different ways on this one, but I'm actually going to go ahead and split it up into 8 pi over 12 plus 3 pi over 12. And the reason that I'm kind of showing you our improper fractions here is to show you how you want to make sure that you're splitting it up into fractions that can be reduced. For instance, here I know that I can evaluate it with a denominator of 6 if need be, right? This ends up being denominator 3, but you want to make sure at least one of them is reducing. All right, so that also, when we have that reduced, so we now have cosine of 2 pi over 3 plus pi over 4. All right, so using our cosine sum, so kind of scrolling back up here, right? So using this formula up here, we are going to have cosine of 2 pi over 3 times cosine of pi over 4 minus sine of 2 pi over 3 times cosine pi over 4. And before I actually evaluate these, I'm just going to kind of point out some things about some formulas here. Is that you can kind of start to see some patterns in there. We didn't actually prove them, but you can if need be. You can go watch a different video on that if you want to. But we like to look at them in terms of, hey, at my sum formula here, I have for my sine is sine times cosine and cosine times sine, whereas my cosine looks a little bit different, right? So my cosine ends up being cosine times cosine minus sine times sine, and cosine times cosine plus sine times sine. So these kind of get swapped up. Just kind of be careful a little bit on those in terms of when you're using your formulas. Okay, so now let's go back to evaluating this. So cosine of 2 pi over 3, that's going to be a negative 1/2 times square root 2 over 2 minus, this is going to be square root 3 over 2 times square root 2 over 2. All right, we have multiplying here, so negative root 2 over 4 minus square root 6 over 4. So final answer here is, again throwing some equal signs in here, negative square root 2 minus square root 6 all over 4. And again, you just evaluated for an angle that was not on your unit circle. So there you go. Very nice job.